Hi, I'm John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. This is part 2 of quadratic inequalities, and on this particular video, we're going to talk about how to solve quadratic inequalities with a less than or equal to sign. All right, and we're using the graphical method. Let's start. When it comes to the graphical method of solving a quadratic inequality such as this, it all boils down to be able to sketch that quadratic curve. So the key things to remember is how do I identify the vertex, the turning point? The shape of the parabola, is it going to be concave up or concave down? That means, is it a U-shaped parabola? Is it an inverted U-shaped parabola? And some of the key points like the intercepts, the x-intercept and the y-intercept. If you've got these key features of the graph, then you'll be able to make a rough sketch of the parabola, and that's it. If you're able to do that, then it's a piece of cake. All right. In part 1 of quadratic inequalities, we solved 2 examples where the question was about greater than 0. The inequality is greater than 0. You could use the same procedure for greater than or equal to 0. Same technique, same procedure. In this particular video, we're going to solve the example where the inequality is less than or equal to. Okay, less than or equal to. You can bring the terms on one side of the inequality and then it's just less than or equal to 0. Same procedure, but a quick thing to remember, the key point is we are looking for values of x where the graph is below the x-axis. Okay, so when it's greater than 0, as we saw in part 1, whenever the inequality is greater than 0 or greater than or equal to 0, we're looking for values of x where the graph of the quadratic is above the x-axis. That's the key thing to remember. And when we have the inequality as less than 0 or less than or equal to 0, we're looking at the values of x where the graph is below the x-axis. So as I said before, it all boils down to making a quick sketch of this graph. The first thing to do is that bring all the terms on one side of the inequality. So you can rearrange the terms and say this is the same thing as 2x squared minus 5x plus 2 is less than or equal to 0. Got it? Now the first thing to identify is the x-intercepts. We can do that. And that can be done by factoring this quadratic. Okay, so the factors would be 2x squared minus 4x minus x plus 2. I'm using the technique of splitting the middle term to be able to find the factors of the quadratic on the left-hand side. So this would be 2x, x minus 2, minus 1, x minus 2 is less than or equal to 0. So we've got the factors as x minus 2 and 2x minus 1. As such, the roots or the x-intercepts, if I write it down, the x-intercepts would be x is equal to 2 and x is equal to a half. Right? Those are the two x-intercepts where the quadratic is going to cut the x-axis. The value of a, the leading coefficient, is 2, which is positive. All right. That means you're going to have a concave up parabola, which means it's a U-shaped parabola. Okay, parabola, something like that. The third thing to also identify would be the constant term. The constant term is 2 in this case, which is going to be our y-intercept. So the y-intercept is, what's that? 2. So the quadratic goes to the point 0, 2. You can also go ahead and find the coordinates of the turning point. I'm just going to identify the x coordinate. So the coordinates of the vertex is going to be, remember, negative b over 2a, and the y coordinate is going to be c minus b squared over 4a. For those of you who haven't seen my video on finding or writing the coordinates of the vertex, I'm going to link that video and the other videos where you can easily factor the quadratic, any given quadratic. I'm going to link those videos in the description box below. Go ahead and take a look at that, and that will help you identify all these key features of the graph. So this is just for the reference, just to give you an idea of where the quadratic is going to turn around. That's also called the turning point. Turning point. Okay, so these are some of the key features. Let's identify the x coordinate. I'm happy with only the x coordinate. If you're interested in finding the y coordinate, go for it. Because as I said, we are only interested in the basic shape. The main question is to be able to find out the values of x where that quadratic is going to be below the x-axis. That's the main thing. Okay, so it's not so much about getting an accurate graph as such. So what's my negative b over 2a? B is a negative 5. So negative b would be a negative of negative 5. And 2 times a is a 2, as we saw before. So it's 2 times 2. And here I can just put negative c minus b squared over 4a. We don't want, I'm not interested in that right now. So then this is going to be 5 over 4, comma c minus b squared over 4a. All right. So that's the x coordinate of the vertex. Now we've got the key features. We've got enough information to be able to make a rough sketch of this parabola. Can you guys see this? All right, I'm just going to make the grid here. Where's my x-axis and y-axis? Here we go. Okay, that's an interesting grid. There we go. I'm just going to mark this as x and this as y. And what do we have? We've got the x-intercept at 2.5. So I'll just make this is, if this is 1, if that's 2, and let's see, this is just approximately, all right? And let's just mark our key points. That's half, and that's R2. And y-intercept is 0, 2. So in the same way, let's just mark that quickly. That's 1, and that's 2, and that's 3. So we want this point. And remember, it's a U-shaped parabola, so it's going to go through all these points, and it's going to turn around somewhere in the middle, right? Because 1 and 1/4 is 1.25. So somewhere at 1.25, approximately there, the quadratic has to turn around, okay? So those are the key points. I am going to make a rough sketch, and it won't be artistic, but it gives me the information that I need, all right? So there you go. Not artistic, but it gives me the information that I need. So this is the main part of the solution, trying to get a rough sketch of the parabola. And you can do that by identifying these key features, the x-intercepts, the idea of the shape of the parabola. Is it going to be concave up or concave down, using the value of a or the sign of a, right? Sign of a being positive, you'll get a U-shaped parabola. An idea of the y-intercept also helps to know where is it cutting the y-axis. And then the coordinates of the vertex will tell you where the parabola is turning around, okay? Having got the sketch of the parabola, then we just look at the question and say, all right, we want to find where is this parabola below the x-axis. Less than or equal to 0 implies where is the graph below the x-axis for what values of x, okay? So here we go. Let's just highlight that region, that portion of the graph. This portion of the graph, green portion of the graph, is below the x-axis, as you can see. And so we're looking for these values of x. Let me see if we can. Okay, these values of x. For these values of x, the graph is below. As we move from left to right, remember I always say read the graph from left to right, okay, from the x-axis, left to right, increasing values of x. You can see that the graph, the parabola is coming this way, right? It's coming down this way, this way, this way. And then at the first x-intercept, which was half, right? Is it half? What did we have? Yeah, x is equal to half was our first intercept. That's where it touches the x-axis or cuts the x-axis. And then after that, it goes below the x-axis and continues that way, turns around at the turning point, and then it's still below the x-axis. And at the second x-intercept, which was x equals 2, cuts the x-axis again and then moves up. So we are looking at only these values of x where the graph is below the x-axis. So then just by looking at the graph, we can clearly see that the graph of this quadratic is below the x-axis for values of x that are greater than or equal to half and less than or equal to 2. All right. And why in this case are we using this sign less than or equal to or less than or equal to? Because in the question, it says less than or equal to. So that's something that you need to keep in mind. Okay. If it says just strictly less than, then maybe your solution just should say strictly less than. Like in the earlier video, we took examples. It was just strictly positive. Okay. Strictly greater than. So we use a solution in that sense. So what does the solution mean? It means for only these values of x, the values of x between half and 2, both inclusive, this quadratic is going to be less than or equal to 0, or in other words, that quadratic is going to be below the x-axis. In the next video, we're going to talk about solving quadratic inequalities using the algebraic approach. See you in that one.